Uh, Okay, so this section, which is partial fractions, we're going to integrate rational functions using the method of partial fractions. And there are three types of problems that we have. That's the simple linear factors, repeated linear factors, and when we have irreducible or quadratic factors. Okay, so let's start off with the fact that we want to integrate a fraction. And this fraction is a rational function. It's one polynomial over top of the other. So what we want to do is we want to be able to take this problem and separate it into a bunch of little things, and then we can integrate each of the little things. So P of X is going to be the whole part. And these little F1, F2, all the way to Fn, depending upon how many we have, are going to be the fractional parts. So we have two cases. The first case of integrating a rational function is when the power of the numerator is greater than or equal to the power of the denominator. So in this case, we use simple long division. Okay. So long division, just like we've done it before, I know you guys remember for long division, does Mary sell balloons, divide, multiply, subtract, bring down? We're going to do the same thing, okay? So we're going to take x cubed, uh-oh, I don't want red. Okay. We're going to take x cubed plus x, and we're going to divide it into x cubed. We have to put in the fact that we have 0x squared. We have to put in the fact that we have 0x, and then we'll put in a -1. So we're going to do regular long division, just like you normally do. Okay, because the power of the numerator and the power of the denominator are actually equal in this problem. Okay, so I know x cubed goes into x cubed one time. 1 times x cubed is x cubed. And 1 times x is just going to give me an x here. Okay, so then I'm going to subtract. And when I subtract, I get x cubed minus x cubed. That's going to give me nothing. 0x squared minus 0x squared is going to give me nothing. I have 0x minus this is going to give me a -x. And then I'm going to have -1. Okay, so actually that was easy. We're done. All right, this is the remainder. So you guys got to remember when you used to do long division, this right here is the remainder. And we always write the remainder as a fraction of what we integrated. So we get the integral of x cubed minus 1 divided by x cubed plus x dx. The whole part is just 1, and the remainder is -x minus 1 divided by the whole, which is x cubed plus x. Okay. All righty. So now in order to do this problem, this looks like, oh, I forgot my integral sign. How could I do that? Let's erase this and squeeze it in. So I have 1 minus this dx. Okay, so this is the integral of 1. The first one is over x divided by x cubed plus x. And then I have a -1 over x cubed plus x dx. All right, so now this is the integral of 1. If I factor x out of every term, I'm going to get 1 over x squared plus 1 minus 1 over, and this is x times x squared plus 1. Now, the first integral is easy. So I'm going to get that integrates as x. The second piece, what's the second integral? What's the integral of this term? What's the integral of that term? Hello? Anybody there?
Arctan?
All righty, thank you. So that's the tan inverse of x. And then I'm still plagued with this last integral because I'm not quite sure what to do with it yet. So how do I integrate integral of 1 over x times x squared plus 1 dx? So this last integral is the type of integral that we're going to figure out how to integrate. So this we're going to use by partial fractions. That would be a partial fractions integral. So we're going to learn how to do that below. Okay, let's look at my second example. Why is my mouse been giving me grief lately? Okay, here we go. Okay, we're going to do this integral. Okay, so in order to do this integral, this is a case where, again, the numerator is greater than the denominator. So this falls under the case of long division. So I have x squared plus 2x plus 2, and it is going into x cubed plus x squared plus x minus 1. So x squared, we always start with the first element. That's the first, that's what we use. So we always use this term. So if you look back before, the only term I used to factor was the highest power. I used x cubed. So I'm going to do that again. This time the highest power is x squared. So x squared goes into x cubed x times, and now I have to multiply. So I get x cubed, x times 2x gives me 2x squared. X times 2 gives me plus 2x. And so I want to subtract. And when I do that, I get negative 2x squared. I'm sorry, negative x squared, not 2. Negative x squared minus x. And then I can bring down the negative 1. Okay, so now I have to take x squared and then negative x squared, and I get minus 1. And so now I'm going to multiply it back out. So I get negative x squared. I'm going to get negative 2x. I'm going to get negative 2. And I'm going to subtract. And then this is going to give me nothing. 1 minus a negative 2x minus negative x minus a negative 2x gives me x. And negative 1 minus a negative 2 gives me plus 1. Okay, so I have a whole part. This is my P of X, is the whole part. And again, this piece right down here, that is my remainder. Okay, so now I get this integral. Is going to be the integral of what I found. So the whole part was x minus 1. And then the fractional part is plus x plus 1 over x squared plus 2x plus 2 dx. Okay, so this is actually a very easy integral. This first piece is the integral of x, so that's just 1/2 x squared. And then I'm going to get minus x. And then the last piece is the integral of x plus 1 divided by x squared plus 2x plus 2 dx. Now to integrate this last integral, it so happens that this one is absolutely perfect for integrating. All right, so if I do this last piece and I let u equal x squared plus 2x plus 2, then du is equal to 2x plus 2 dx. But that says that du, factor out the 2 guys and get x plus 1 dx. And oh, look at that. There is x plus 1 dx in my problem. X plus 1 dx in my problem. So now I get that 1/2 du is equal to x plus 1 dx. So this one worked out really nicely. So now we get that the integral of x plus 1 over, oh, I'm not going to have enough space to write. Let me move it down. The integral of x plus 1 divided by x squared plus 2x plus 2 dx is equal to the integral. X plus 1 dx is 1/2 du. And then the denominator is just u. So this is 1/2 the integral of du over u. And we already know that's the log of the absolute value of u plus a constant. So this integral simply becomes 1/2 the log of the absolute value of x squared plus 2x plus 2 plus a constant. All righty. So we got a little detoured, but we're back on track. So now we get this integral. The first part was 1/2 x squared. Then we got minus x, and now we have 1/2 the log of the absolute value of x squared plus 2x plus 2 plus a constant. And we are done. Okay, so here, believe it or not, everything that I've done thus far are things that we already have known. Okay, that is either we knew how to do the long division from algebra, okay? Or we knew how to do a U substitution problem and it came out perfect. Okay, so that's the case when the numerator is greater, the power of the numerator is greater than or equal to, you do long division. Okay, so this is where we now go into what we really want to learn, which is partial fractions.
After a while, I have a question.
Yes.
Why'd you switch the sign where it's like minus 1/2 log?
Did I make a mistake?
Oh, I don't know.
Where did I get minus 1/2 the log? Because that should be a plus.
Okay.
Okay, big catch there. All right, so in case number 2, which is the major case we want to learn in this section, and that's the case when the power of the numerator is less than the power of the denominator. So this is case 2. And in this case, we're going to have 3 different options. One, the first option is to find the linear partial fractions. Okay, so I want to show you how to do that. First thing I want to do is give you the technique. So I'll give you a second to write the technique down. So here's the technique. I decided every time I teach the course, I try to do something just a little different to see if it helps. So this time I decided to write the technique out. Okay, so the first thing you're going to do is split the rational function using factors of the denominator. Then you're going to find the roots of the denominator. They're going to be R1, R2, all the way up through Rn. Then you need to find the major equation. So I have to tell you how to do that. And then you're going to use the roots to solve the major equation for any variables that you created, A, B, C, or whatever. Choose additional values of X. This is if necessary. So I meant to put comma. This may not be necessary. And then substitute back and integrate. Okay, so that's your technique. All right, and so we're going to use this technique on a couple of problems. All right. And as I do it, you will see how each piece works. Okay. So the first example is this one. Okay. So now, as you can see, this is a rational function. It is 4 over x plus 2, x minus 3. The power of the numerator is less than the power of the denominator. So we're going to go ahead and find linear factors. And so now we're going to split the rational function using factors of the denominator. Okay, so we're going to split this using factors of the denominator. So we're just going to, I'm not going to worry about the integral part. I just really want the inside part. So let me see if it'll give it to me. Or do I have to retype it? Oh, it looks like it's going to make me retype the whole thing. Yep. Okay, get rid of dx, that's good. Okay, it's not going to let me get rid of the integral. Okay, that's fine. All righty, so let's only worry about the integrand. So for the integrand, we have 4 over, and this is already factored for us, x plus 2 times x minus 3. So we have two linear factors. So with those two linear factors, I'm going to say A over the first linear factor, which is x plus 2, plus B over the second linear factor, and that is x minus 3. Okay, so as you see, now we have done step A, which is split the rational function using factors of the denominator. So we split it into A over x plus 2 plus B over x plus 3. So that was step 1. Okay. Step 2 says find the roots of the denominator. Okay, so for step 2, what are the roots of the denominator? What are my roots? X is equal to
-2.
-2 and
3.
+3. Okay, so those are my roots. That's step 2. Okay, so now we're going to find the major equation. So this is how you find the major equation. We're going to take the least common multiple of the factors in the denominator. Okay, so the least common denominator. So our LCD, so for step 3, we find the LCD. God bless you. Is equal to x plus 2 times x minus 3. So we're going to multiply this equation by that. So I have x minus 2 times x plus 3, and that's going to multiply 4 over x plus 2 times x plus 3. And on the other side, I'm going to take x plus 2 times x minus 3, and I'm going to multiply by a over x plus 2 plus b over x minus 3. Okay, so now here, I got to use the distributive property. Okay, so notice now, here, x minus 2 divides with x plus 2. Oh, no, it does not. What is it supposed to be? X plus 2, x minus 3. I done changed the whole problem. Make this go back to what it was. X, this is x minus, yep. This is x plus 2, x minus 3. Okay, now it's right. Just got to be careful in my algebra here. All right, so now x plus 2 divides with x plus 2, and x minus 3 divides with x minus 3, and that leaves me 4. Okay, now when I distribute, I get x plus 2 times x minus 3 times a over x plus 2. So the x plus 2s are going to divide out. So I'm going to get a times x minus 3. Then I'm going to get x plus 2 times x minus 3 times b over x minus 3. And the x minus 3s are going to divide out and give me b times x plus 2. And this is my major equation. So that's my major equation. Once I find the major equation, I'm in good shape. Okay, so now we found the major equation. Step 4 says use the roots to solve the major equation for any variables. So here we have two variables, A and B. So in step 4, we are going to use the roots. So let's let x equal -2. So if I let x equal -2, I'm going to put that in the major equation. So I get 4 is equal to a times -2 minus 5. I'm sorry, -3. Got the answer already. Plus b times -2 plus 2. Well, isn't that wonderful? That's 0. So that's going to go away. So I get 4 is equal to -5a. So now I know a is -4 fifths. Okay. Now I'm going to use my other root. Let x equal 3. So I'm going to get 4 is equal to a times 3 minus 3. Well, that's wonderful. That's going to disappear. Plus b times 3 plus 2. So I get 4 is equal to 5b. So now I get b is 4 fifths. So now that I know a and b, I can go back to my original problem, which was this step right here. So we didn't have to choose any additional values for x because we're done. We solved for all of a and b. So now a, we said was -4 fifths. And b, we said was +4 fifths. Alrighty, so in last step, we can skip step 5. So step 6, we can now actually compute the integral. Because now we know that this is simply equal to the integral of -4 fifths times 1 over x plus 2 plus 4 fifths times 1 over x minus 3 dx. And that's easy to integrate because I get -4 over 5 or -4 fifths. And then this is the log of the absolute value of x plus 2. We learned that earlier. Plus 4 fifths times the log of the absolute value of x minus 3 plus a constant. And we are done. Now, I'd like to do some more with this, but I'm good if y'all get that far. So let me just show you where we actually can go with this. We can factor out the 4/5 and make it the log of the absolute value of x minus 3 minus the log of the absolute value of x plus 2. And if we wanted to go even further, we can make this 4/5 the log of the absolute value of x minus 3 divided by x plus 2 plus a constant. Okay, but I'm willing to take this answer. Okay, any questions about that? Nice, easy one. All right. So again, when you get to the major equation, that's where you can go ahead and use your roots to solve for any constants that come up. All right. Here's the second one. Okay, the next problem looks like this. And this is not factored. Okay, so it's not factored. So I have 4x squared plus 1 divided by x cubed minus x squared minus 6x. 4x squared plus 1. Let's factor out the x. X squared minus x minus 6. Okay, we're almost there. 4x squared plus 1. Almost completely factored. This is x. I think this is x minus 3 times x plus 2. That is correct. Okay, so now we have it in factored form. All right, what's step 1? All right, so step 1 says split the rational function using factors of the denominator. Okay, so I have 3 factors. I have x minus 3, and x plus 2. Are they the same factors as before? Oh, I wish I had something different. All right, we're going to change this. I'm not doing the same problem. So this is -5. Oh, wait a minute. -5 doesn't work. Oh, yes, it does. -6 and +1. Yes, it does. I'm not using the same factors. So this is x plus 1, x minus 6. That works. Okay. Gotta do something different, something different. All right, so now we have 4x squared. So step 1,
Excuse me.
yes,
I had a question. It ain't about like this necessarily. I was trying to see when the next test was.
it's when we come back from break on Thursday. It's the Thursday after break.
All right.
Okay.
Okay. Are you gonna put on Blackboard what it's gonna be on?
Absolutely.
Okay, thank you.
Mhm. Okay, so split the rational function using the factors. So we have 4x squared plus 1 over x times x plus 1 times x minus 6. So we're going to do a over x plus b over x plus 1 plus c over x minus 6. Okay, so that's why I said I wanted to do something different. Okay, so that's first step. Find the roots. Okay, so step 2. So what are the roots? X equal to 0, -1, and 6. Okay, so far so good. Find the major equation. Okay. So we're going to take step 1 and multiply by the least least common denominator. So for us, the least common denominator is just x times x plus 1 times x minus 6. So in step 3, we're going to get x, x, come on now, do what I want. Oh, that was right. No, it wasn't. X times x plus 1 times x minus 6. And that is times 4x squared plus 1 divided by x times x plus 1 times x minus 6. And that's going to equal x times x plus 1 times x minus 6. And that is going to multiply a over x plus b over x plus 1 plus c over x minus 6. All right, any questions? All right, so can anybody tell me what the major equation is? Help me get the major equation. What is it going to be?
Can I try?
Yes,
Can I just do like step by step?
yes, guy, that's what I want.
Okay. So you would, on the left side, you would cross out the red and the denominator, and it would just be 4x plus 1.
Good, okay, so 4x squared,
Oh, yeah.
okay,
And then that would equal to a over x plus 1 times x minus 6.
okay, it's actually times, not divided by.
Oh,
They're in the numerator. So the first one, the x's divide out, and you keep x plus 1, x minus 6 in the numerator. Peyton.
Yeah, sorry.
Okay, can you keep going?
Yeah, so then it would be plus b times x minus 6. And plus c times x minus 1. No, plus 1.
Okay, that's it. What color did I make it before? Green, blue. I like to kind of keep my colors. So if I'm doing all the major equations, they're gonna all be in blue. All right, so I found the major equation. All right, so that's the equation I am going to use to solve for A, B, and C. All right, any questions? Thank you, Peyton. Okay, so step 4, we use the roots to solve the major equation for the variables. And now we have A, B, and a C. So we have to solve for 3 variables. Okay, so step 4. All right, so our first root is x equals 0. Okay, let's work with that. So let's let x equal 0. And we get 4 times 0, which is just 0 plus 1. Is equal to a, and we're going to put in 0. So we're going to get 0 plus 1 times 0 minus 6. Then we're going to get b, we're going to put in 0. Oh, well, that's going to knock everything out, so we really don't care. And then we're going to put in c, and up, that's going to 0 is going to knock everything out, so we don't really care for that either. Okay, because we put in 0 for x. So on this side, I get 1 is equal to a times 1 times negative 6. So now I know a is negative 1 over 6. Okay, any questions about that? Okay, my next root was negative 1. Okay, so I'm going to get 4. Negative 1 squared is 1 plus 1. So that's what I get on the left-hand side. So I get a. When I put negative 1 in there, oh, that's 0. So I don't have to worry about that. Plus b times negative 1 times negative 1 minus 6 plus c times negative 1. But when I put negative 1 in there, I get 0. So on the left-hand side, I get 5 is equal to a times 0 is gone. I get b, and I have negative 1 times negative 7. So that's b times 7. And then that's gone. So I get b is 5 over 7. So now I know b. Okay, I have one more root, and that should be 6. Okay, so let's let x equal 6. So now I gotta go back to the major equation. So I get 4. 6 squared is 36. Plus 1 is equal to a. 6 plus 1 is 7. When I put 6 in there, I get 0. So that's gonna go. I get b times 6. When I put 6 in there, I get 0. So now I'm going to get C. When I put in 6, I get 6, and then I'm going to get 6 plus 1 is 7. Okay. Oh, 36 times 4. What in the world is that? $144. So this is going to give me 145. Does everybody see where I got 145? I plugged it into the major equation. 6 squared is 36. 4 times 36 is 144. Add 1, you get 145 is equal to A is gone, B is gone, C times 42. So I get 42 times C. So C is equal to 145 over 42. Okay, any questions about that? So I solve for A. I solve for B. And I solve for C. Okay. All righty, substitute and integrate. Okay, so let's substitute. So where was my original problem? Here it was. So in step 5, I have A is negative 1 over 6. I have B is 5 over 7. And I have C, which is 145 over 42. That's reducible, isn't it? 3, no, it's not. It is not reducible. 3 does not go into, no, not reducible. Okay. All right, so now we integrate it. Okay, so this is equal to the integral of what we found. So we found minus 1 over 6 times 1 over x plus 5 over 7 times 1 over x plus 1 plus 145 over 42 times 1 over x minus 6 dx. So therefore, when all is said and done, we get negative 1 over 6, the log of the absolute value of x, plus 5 over 7, the log of the absolute value of x plus 1, plus 145 over 42, the log of the absolute value of x minus 6, plus a constant. And we are done. Okay. Questions? Does any of this seem difficult? I mean, the algebra, you got to work through the algebra, but this is a pretty straightforward method for the cases, those two cases that I covered. Okay, so these cases were linear factors. When I say linear factors, x is only to 1 power. All right. Here's our technique. Okay. Of course, everything that we start off with is always the easiest case. So now let's go to the more difficult case, which is repeated roots. And it really is not that difficult. We just have to use step 5. Okay, so repeated roots. So we're going to have some examples. All right, so repeated roots is when your factor appears to a power in your denominator. This gives us problem number 3. Okay, so in problem number 3, we have 3x plus 2, and it's divided by x cubed minus 2x squared. So I'm going to write it as 3x plus 2 divided by, let's factor out the x squared, and we get x minus 2. Okay, that's the best I can do. All right, so I factored it. I can't factor it anymore. Okay, so now that I factored it, I'm going to split it up. So I'm going to get 3x plus 2 over x squared plus x minus 2. So that's going to give me a. Now notice x squared, x appears twice in the denominator. So I need a over x, and I'm going to need a b over x squared. And then I'm still going to need the c over the x minus 2. So since x appears twice in the denominator, I have to do an a over x and a b over x squared. If it appeared 3 times, I would need a c over x cubed. However many times, okay. All right, so now that I have that, what are my roots? Well, my roots are x equals 0 and 2. So now we're thinking, oh boy, every time we used a root, we were able to solve for an a, b, or c. This time I only have 2 roots, and I still have to solve for a, b, and c. So this is where step 6 is going to come in. We're going to have to choose some other number to help us out. Okay, and we'll choose something small. So let's find our major equation. Our least common denominator is x squared times x minus 2. All right, so I'm going to take x squared times x minus 2, and I'm going to multiply it by 3x plus 2 divided by x squared times x minus 2. And then on the right-hand side, I'm going to do x squared times x minus 2. And I'm going to multiply by a over x plus b over x squared plus c over x minus 2. Okay, who wants to give me the major equation?
Can I? Again,
Okay,
so on the left, it's going to be 3x plus 2. 'cause
okay,
they cancel.
all right,
A times x minus 2
right. 1x stays, that's very good.
plus b times x minus 2. And then plus c times x squared.
Okay. All right, so again, that is the hardest part, literally getting to the major equation. Once you get to the major equation, then you just have to start using your roots. But this equation has to be correct. Okay, so our next step is to use our roots. So we're going to let x equal 0. So I'm going to get 3 times 0 plus 2. So I'm going to give me a 2. I'm going to get an a times 0. Good, that's gone. Plus b, 0 minus 2. Plus c times 0 squared. So that's going to be gone too. So I get 2 is equal to negative 2b. So b is equal to negative 1. Ah, 1 down. All righty. Now we want to let x equal 2. That was our other one. So I get 3 times 2 is 6, plus 2 is 8, is a times 2, oh, but that's times 0, so that's going to be gone. I'm going to get b times, up, that's going to be 0, so that's going to be gone. So I'm going to get c times 2 squared, which is 4. So now I get 8 is equal to 4c. So c is 2. All right, we're out of roots. Okay, this is, so as I said, we are out of roots. We only had 0 and 2 because 0 appeared twice and we've used it already. So now we go back and look at what our steps said. And this is the case where we now have to use step 5. Choose addition, that should say additional. Lord, help me. Additional.
I have a question.
Yes.
What is to clarify? Roots, the number of roots is based on how many variables?
So no, okay, so the number, so in this problem, the roots are whatever makes the denominator 0. So 0, -1, and 6. So you put 0 in here, it's 0. You put -1 in here, it's 0. You put 6 in here, it's 0. So I find the roots of the denominator. So this one had 3 roots. So does this one, the one we just did. The one we just did had 3 roots. They are 0, 0, and 2. So this does have 3 roots. 2 of them are just 0. Because this is x times x times x minus 2. So you get a 0 from here, you get a 0 from here, and you get a 2 from here. So you actually do get 3 roots, but 2 of them are the same. That's why it's called repeated root. So this is the case where 2 is the 0 is a repeated root. So when that happens, I'm short. I don't have another root, and I still don't know A. So now at this point, you just choose an X. So I ain't getting nowhere near where I need to be. Now, we can all choose a different X. I am not going to choose a big X. I would always choose X equals 0 if I could, but I've already used it. I don't like choosing negative numbers. They're a pain. So the smallest positive number we haven't used is 1. So I'm going to choose X equals 1. I could have chosen anything I wanted. This would still work. I'm just choosing something nice and simple. So on the left-hand side, I get 3 times 1 plus 2, so I get 5. On the right-hand side, I get A times 1, which is 1, times 1 minus 2, so I get negative 1. I get B. Well, B is negative 1, times 1 minus 2, so that's going to be negative 1. And then I get C, which is 2, times 1 squared, which is 1. Okay. So I get 5 is equal to negative A. This is 1 plus 2, so that's 3. Everybody see that? Negative 1 times A. And then I get B, which is negative 1. I get 1 minus 2 gives me a negative 1. And then I get C, which was 2, times 1 squared. So now I get 2 is equal to negative A. So now I know A is negative 2. So that I am now done. Okay. So when you run out of roots, you got to make up one, pick one. Okay. So now let's go back to the original problem. Up here it is. All righty. So A, I know is negative 2. B was negative 1. And C is 2. Okay. So now I'm going to integrate that. So now my original problem, which started here, okay. The integral of negative 2 times 1 over x minus 1 over x squared plus 2 times 1 over x minus 2. That whole thing gets integrated. Dx so this is going to equal negative 2 times the natural log of the absolute value of x plus 1 over x. When you integrate x to, so this is negative x to the negative 2. So when you integrate that, you get 1 over x plus 2 times the log of the absolute value of x minus 2 plus a trusty little constant. And there we have it, the answer to the problem. Okay. Any questions? All right. Well, we're running out of time and I am going to go ahead. Oh, no. This next problem, we can set it up. And you guys can finish it. It's also a repeated root problem. All righty. So now you can see x minus 1 is cubed. So I'm going to get x cubed minus 2x plus 1 divided by x times x minus 1 cubed. I did not take attendance. Let me take attendance. You are right.